Hi everyone, this is your instructor. I'm going to be talking about discrete random variables today. As you can see, this chapter basically inculcates within the students the concept of the difference between a random variable and a continuous random variable. Continuous in the sense that you can have various values attached to the variable, which is in itself, it means that it is going to be having variable or varying values. So we have two kinds in this case. First of all, the discrete random variables and the continuous random variables. So now the discrete, as the name says, something which is very concrete, which can assume whole values and that they are countable. However, they could be countable, but in the sense that they can have 0, 1, 2, 3, 4, so whole numbers in a real number line. You can just they're not between intervals, so there's just assuming like chunk forms. So from 0, then 1, then 2, so you can just count them. And now they could be, they could be finite or infinite. That's a separate issue. So, but sometimes they can assume whole values, but that is the main point, that they should be having whole values. They can be counted, and if they are not countable, then they would not be having. That means you can say they are not finite in the sense they are infinite. So there are two concepts which are involved. So first is that either they are finite or infinite, and then whether you can count them or they are uncountable. So for discrete variable, then they have to be either of these. They could not be counted because they're so large. Like I would say, the number of stars in the sky. This would actually mean a lot of measurement because it's not possible at the moment to count all of them. So while they're whole, they're not incomplete and they're not in intervals, but they cannot be counted. So that means that it is something which could be infinite, but in the same sense, it could be something which is countable if presented in small quantities to you. Similarly, then there is something which is not countable because it is lying in the intervals in the real number line. So the real number line is from negative infinity to, let's say, positive infinity. So all the values that are involved in between those intervals, like those values which are lying in between the intervals on the real number line, they are not countable. Even it is something which is finite, however, still you won't be able to count them. So for instance, I say the mileage a car could have per se one city to another while traveling in completing number of miles in 1 gallon. So I would say that from let's say one city to another you can have maybe 10 miles per gallon. However, if it is assuming in decimal form, so it's just, let's say, 1 over 100th of a value, 1 over 10th of a value, that means that decimal value is something which you cannot put a finger on as an exact amount, because I would say, let's say 10.4 miles per gallon, but then are you sure it's 10.4 and it's not 10.41, 10.40, 10.01 or 10.39, 10.391. So it's something which is in decimals. So it's always not possible to count that because it could assume many values that they are infinite in between those 2 points. So that is why we could say that something which assumes the values which are in decimals running in 1 over 100 or 1 over 10 or fractional part of the whole would be a continuous random variable. So why it is random? Because it is assuming different values, and it's a variable because of the same thing that it's not accurate. You cannot tell for certain that this value is going to remain the same. So it is uncertain. That is why we say that, and it's unbiased. We are not biased towards having, or we're not tilted towards one result in this case. So that is why we say we have now discrete random variables, and then we have continuous variables, because for continuous you need to have decimal system in place. Now let's just talk about what are the learning objectives in this case. We have, like I told you, the difference between a discrete random variable and a continuous random variable. Then we have probability distributions. So, okay, now what is a probability? Probability is that it could occur with uncertainty. There's always uncertainty attached or involved with having the surety or unsurety with an occurrence. So we have uncertainty in place for the number of outcomes that we could have, per se temperature or the weather. Then we could have probability which is associated with whether it could be hot or it could be cold, or it could be continuous, or it could be a whole value. However, when you have let's say temperature, then now this could be a continuous variable, and the probability could also be maybe just say 50% chance that the temperature is going to go down, or 99% chance that it's going to remain the same. So when you have such chances that are involved, you have probability along with it. So therefore we have probability distribution for each day, for instance. So x could be the number of days that we're talking about. The day first, we say the temperature is going to 50%, it's going to remain the same. The second day, it's going to probably become partially cloudy, and the third day it could be overcast, and the fourth day it could be raining. So this is so how much is it raining? There is a chance that it could be 40% probability that it could be raining. So we can have probability along with the values of x. Now x could be anything the question can ask you about, or let's say it could be any main focus of our inquisition. So now today what we're going to be doing is just going to be giving you an intro how to calculate standard deviation. So we have random variables, binomial, Poisson, and hypergeometric distributions that we're going to be doing in the next lectures. I guess it's just going to be one or two more lectures. So now, okay, let me just go towards the next section. Okay. So now, as you can see, a random variable that assumes numerical values that are determined by the outcome of an experiment. So obviously, there has to be some kind of an experiment, there has to be some kind of an action in place to determine something. That is meant by an experiment. It's not something that you do in lab. It could be anything, any action that you take to achieve a desired response, result, or answer some inquisition or question or query. So where one and only one numerical value is assigned to each experimental outcome. So how do you assign one numerical value? Like I told you, day first, day second, day third, day fourth, or it could be mileage, it could be temperature, the weight on the weighing machine, the weight of students, of people, or the number of magazines that are sold, the kind of investment that you're doing, so the amount of profit that is attached, the probability of that profit with every year that you are investing money. So it could be an insurance policy, anything. So that is the discrete random variable, means you finite number of possible values in the form of a countable sequence or lists such as 0, 1, 2, 3, so you can count. A countably infinite list could also be, like I told you, gave an example of stars. They could be countable, but since they're infinite, it's not possible to keep on counting them forever. So some of the examples are customers entering a store who will make a purchase. Okay, X could be, and values are giving you a number of values here. So the number of X of patients taking a new antibiotic. So for instance, there are people who have some sort of gastrointestinal problem or distress based on the consumption of antibiotics. So in this case, how many patients are going to be reporting sick? That's what they're saying. So it could be a 0 patient. None of the patients would have any side effects. It could be 1 patient coming, 2, 3, or 4. So it depends upon the question. The main objective would be as X. So if the objective is basically to have the focus, that is the object, to focus on that object of our question. So in this case, the object would be television. So it's a sample of the number of sets that are old and they don't need a single repair. So it could be 0 televisions, 1, 2, 3, 4, 5, 6, and so on. So similarly, we have fires, then that is obviously countable, and then there's no probability that it is infinite because obviously it's something finite and countable. And but sometimes it becomes uncountable if you have the number of trees in the forest. You can't really count all the trees and the branches. Sometimes it becomes nearly impossible to do that. But it's not that it is not countable. Sometimes the conditions persist that it's not possible to count. But in this case, there is no such thing. We do have the possibility, probability, we have the means to count them. So you have dirt specks. Okay, so now another example. Dirt specks can't really count the specks. Can't really count dust, can you? But the number of specks, if you are just counting how many blotches on a 1 square yard sheet of wrapping paper or whatever that you have in place, you could be a piece of cloth that you have. So you can have dirt specks. So those specks, if you're talking in terms of round blotches, large blotches, then you can count them. But if it's about the number of fine grains that are attached to a molecule, the atoms can't really count them. So it becomes something which is not countable, but it can have whole values. Similarly, we have, as you can see, continuous variables. Then you can find out the difference and you can answer question 1 in this section, which tells you about explaining the concept of a random variable, and then second, where they're asking you the values, how are they different from the values of a continuous random variable. So the continuous random variable, as you can see here, they're giving a very nice fine example in this case. Car mileage, like I gave you. So EPA's Environmental Protection Agency combining city and highway mileage of a randomly selected mid-sized car. So we have continuous random variable because mid-size is just medium-sized cars going from one city to another. So no, they're talking about mileage as 1/10. See, so 1/10 means it has assumed decimal proportions, and we have, technically speaking, something which corresponds to, let's say, 26 miles per gallon. Then that is an interval on the real number line, because try listing the mileage starting with 26 mpg. Would the next mileage be 26.1 mpg? Are you sure about that? Are you sure that it is not 26.05? And then again, are you sure that it is this? Because no, you could obtain a mileage of 26.025. Before 0.1, there always is a decimal value which is lesser than 0.1. So it could be 0.05. But then again, there is some value, again, lesser than 0.05, just 0.025. So it is continuous. And there will always be another mileage. It means in the interval-based system, there's always one value which is before the value ahead. So then we have other examples. Similarly, we have interest rate percentage, anything in percentage, in seconds, in decimals, the weight, the temperature. In this case, it's the strawberry preserve, the jam, the pickle that you have. So I think this concept should be pretty clear to you now. They've asked you the difference of the variables as discrete or continuous. Okay. So now, in this case, all right. Let me just help you with this question a bit so you can just really practice other examples. So we have the number of girls born to a couple who will have 3 children. Obviously, these are girls that are countable, it's finite. So this is discrete. The number of defects found on an automobile at final inspection, obviously this is discrete because it's countable and finite as well. But the weight in ounces of sandwich meat placed in a submarine sandwich, this is something which is continuous, it's not discrete because it is interval based. And like I told you, in continuous, whenever you have something continuous or in continuity, then that assumes continuous random variable status. So we have incorrect lab procedures. Again, this is discrete because you can count the number of procedures that have gone haywire and the number of customers served during a given day. Obviously, that is could be 80 customers coming to the driveway, could be 100 customers coming to. So time needed by clerks. This is also discrete. The time this is to complete a task. In this sense, it could be continuous because it could be in decimals. So you can't really measure time as whole exact 1 hour. So it could be whole discrete if it's just 1 hour, but since an hour is comprised of minutes and of seconds, and how many seconds have passed, you can't really tell. So there could be exactly 59 point something minutes have crossed, then it could be 16 minutes leading to 1 hour. So you can have decimal values in place, you can have continuous, and then this is temperature, this is continuous. Okay? Then we can go towards the next section in this case. So now, as you can see, the sections, as you can have binomial, Poisson, hypergeometric, and covariance. So that will be covered, I guess, in the next lecture. Hopefully, it's going to be a long lecture, but this one is just a, sort of like preparation in advance for the next series. So it's very interesting. It's going to be very interesting, and we're going to be doing it on the board. So I just hope that you keep your done. Now, again, probability distribution. I've already told you this part is something telling you about true sound car radios. Okay, so the number of radios that are selling in a week's time. So if it's just 1 week, so that would be out of the total number of weeks that, as per them, so they say that X is the number of radios that are sold. So it's 0 radios sold, 1 radio sold per week, 2 radios sold, and 3 radios sold per week. So the number of radios sold. If how many weeks have gone by where this radio was sold, and the total number of weeks that were meant for selling. So let's say the shopkeeper is active for, in this, according to this example, it says that 100 weeks. This total 100 weeks are allotted for selling, and out of those 100 weeks, either you could be using 2 weeks for selling of in the first 2 weeks could be 0 radio sold, or the first week 0 radio sold. So then the number of radios could be the values which X assumes, and then you can see 50 weeks with 2 radios sold, so that would be 2, and since now how you determine the probability would be 50 out of the 100 weeks which are totally allotted for or allotted in total for the selling part. So we have 50 by 100 in this case. Let me just reiterate this part. The number of weeks which are allotted for selling are 100. And out of those 100, then they are giving you the probability that 0 radios were sold in, let's say, first week. And or it could be 2 weeks. So for this case, we have 3 weeks with no radios sold. So that means 0 for X, where no radios are sold, and 3 out of the 100 weeks, we have 3 weeks with 0 radios sold. So the probability in this case will be 3 by 100, which is 0.03. Okay. So now, as you can see, the probability distribution is above. Now, when they say probability of X is 2 equal to 2, it means that for X having value of 2, what would be the probability? In this case, would be 0.03, like I told you, this is 3 out of 100 weeks. So let's just go down and see. Okay, so now you can see that probability is 0 where X is 0. So no radios were sold for the first 3 weeks, and it could be, or out of the 3 weeks were such that where no radios were sold. Out of the total 100 weeks, it could be having the same arrangement in one go, or it could be based on random observation of perhaps intermittent weeks. There could be gaps in selling. So it could be 1 week where they're selling, second week where could not be selling. So in total, they say that there are 3 weeks where no radios were sold out of the 100 weeks. So the probability that 0 radios were sold is actually 0.03. So 1 radio where X is equal to 1, as you can see, it says 20 out of 100. So it's just that there are 20 weeks where 1 radio was sold per week. So it's not just that in 20, students often have a problem of, misinterpreting this part. They would say that or think that probably 20 weeks went by where this 1 radio was sold. No. 20 such weeks were out of the 100 weeks where just 1 radio was sold. So it could be 100 weeks, and then you have out of those 100, 20 weeks where just 1 radio was sold, right? And it could be not in one go, like I said, it could not be in some continuous fashion, it could be intermittent with gaps. It is something which is spread, randomly, and it could be with differences, and it could be with intervals. So we have, again, where two radios were sold 50 by 100, and as you can see the statement, I will just read the statement for 50 by 100 to you. As you can see, they have just mentioned here that 50 weeks with two radios sold. So now you can see the 50 weeks. So for two radios were sold, there were out of 150 such weeks where just two radios were sold, and with 20 such weeks where three radios were sold, and the sum of the probability should be equal to 1. So we have then all these probabilities, so 5, 6, 7, and then you have 5.5, 0.7, and then you have this is 0.1 again, 5, 6, 7, 8, 9, and then it is 0.1 is 10, so it's just 1.0. In this case, it's just 100%, because out of 100. So how do you find that out? It's just 50, 60, 70, 80, 90, and then 5, 6, 7, 8, 9, 10, so it's 100. So all in all, it cannot exceed this 100, alright? So then we have summation probability, like I've already mentioned to you, and they've already stated here that it's equal to 1. Sum of probability is equal to 1, right? Then we have, the mean, something that you should remember, that when you multiply the value of x with the probability, that would give you the sum, would give you mu, okay? So in this case, we have 0 probability, 0 radios, and then selling 0 is 0 because this was not in consideration when no radios were sold. We have 0.03 is the probability of 0. So when we had 0 radios sold for a particular time period, and that was, I guess, 3 weeks, so we had 0.03 is 3 out of 100. So multiplying 0 with 0.03, then we have, again, just multiply the value of x with the probability that it has, and you get sum of 2.1. They've just given you the statement form of this. Now you can they're just basically trying to tell you how are you getting mu, why are you multiplying it to get mu, because generally mu is supposed to be for population, where you divide the number of total values that x has over n. Again, this is the same thing. N is basically divided, it's just divided by n. So what do you have? N as 100, so you just divide all the values of x by 100, okay? So, but now in this case, x is not alone, because x is not for sure. So x has a probability which is attached to it. So normally we have, how many radios sold. So for instance, in this case, they have told you 0 radios in the span of 3 weeks. So it's just 0 radios for the first. And then we have 1 radio in 20 of the 100 weeks. Okay? So it's 20 weeks, just 1 radio. You can just have 20 radios. So you are multiplying per week. It's just 20 such weeks where you have 1 radio per week. So you can just multiply that per week with 20. And if you have 50 radios, 2 radios in 50 of the weeks, that means for 50 weeks, 2 radios per week would give you 50 into 2, so you have 100 radios. And similarly, so on and so forth. You just add those values, and then you can have just 210 by 100. So now, basically, this is if rewritten in another way, as you can see here, can be written as 0 to 3, 1 and 20. Now, as you can see, this is 1 into 20, 50 by 100. They've already given you that out of 50 weeks, this was this. That means that out of 50 weeks, 2 radios per week. You're multiplying this value, but then this value is actually a percentage of the total number of weeks that were involved. So either you individually divide it by this, it's automatically your probability. So that is why you're multiplying that with the probability instead of going through with all the derivation here. So then you can just get summation xpx, and then that is again the so we have another issue where you have profit policy holder lives with some profit of $300, and they're giving you a probability of Px as the profit probability that the policy, if it is either the person is living or the person is dead. In this case, if the person is alive, they will be earning a profit of $20,000, and with the fact that they would also be earning the premium over it. If the person dies, then they would be losing actually. So this loss could be as minus 19,700. And now this is basically the premium. And if the policy holder lives, he also has to pay the premium. The company would be earning, some profit to value, which is actually the probability that he's alive and you are getting, $300 is 0.99, and then you can have the premium value, let's say, and then you have minus, which is a loss in case the policyholder dies. So this is a premium minus the $20,000 because this is something that you forego. So when you forego something, it is something that you have to let go because that profit is not anymore service which you already gave, I guess. So now you have minus 9,700 in the probability. So this is 280. Now how do you get this value actually? As you can see, this is a bit above. They've shown you this is the premium. Let's say that we wish to find the premium that insurance company must charge $20,000 policy if the company wishes the average profit per policy per year to be greater than $0. So it has to charge amount in order to earn profit that's $20,000. So if you get premium, premium the company will charge. So that means the probability distribution. Now they're just giving you a probability distribution of 0.99 to 0.001. So you have premium multiplying with the probability of the holder living and the probability when he dies and you lose out on the premium. The premium is still given to you, you lose out on the profit, and then you multiply it. So you can get 0.99 to $300, and $300 minus $20,000 minus 9,700. And then you can see that since this is a very, it's not very likely that the person is going to die, but you can see that the amount of loss. So now why are you adding the premium? Because that person would pay the premium at the beginning of the policy, but he would not be paying the $20,000, which would be actually for availing the policy if the person died in the middle. So this loss is huge, even though the risk is small. But so many people die and the policy could be, the policyholder could die and the policy could in itself die as well. So it is risk. People are not very risk friendly or risk pro, so they will not be willing to take so much risk, even though the chances are very small in this case. You can say that this is 0.01, it's minuscule house. Still people would not want to take this. You can just analyze this part. If in the question it's asked from you, so you're supposed to just first put your analysis. Now again, they've just given you that standard deviation, how you're supposed to calculate this. Just already how you calculate XPX, right? So this XPX is basically your mu. Let me just go up so you can see that this was your mu. This XPX is your mu, right? So similarly, that is just like X bar when we calculated standard deviation. What we did was X minus X bar. So first of all, you have X minus mu, and then you can have X minus mu, then just X minus X bar squared, the way we did in previous lectures, and then you can have X minus a mu squared, and then again multiplying it with the probability distribution of Px, you could be getting the value of variance, and then you just simply take the square root. So let's just look at this procedure. What we've done is that the mu squared to Px, right? This is first value of X minus the probability distribution is such that you can have the mu. How you have that mu? Just have the probability distribution multiplying it together. Let us just do a question. Okay. Now after this we have the Chebyshev theorem with us, where they're asking us about the time the standard deviation would be, plus mu or added with the mu or subtracted, from the mu in order to give us interval. So this interval could be 2 standard deviations, could be 3 standard deviations, could be well above 88%. And if it is 2 standard deviations, which is 75%, 3 by 4 in this case. So we can have Standard deviations bring the mean mu, and this is the interval that they are telling you about. So this is the interval. So we have either negative or positive. It could be 2 standard deviations or 3 standard deviations or just single standard deviations. This is a probability distribution as per the Chebyshev's theorem. So we have 1 minus 1 over k squared. It basically means that Chebyshev's theorem, as you've already done that, I'm not going to be repeating that. Please go back to chapter 3 and you can just see that we have k is the number of times for standard deviation. So we can have this as would lie within the interval of plus minus mu, and then we can have this is now we have already told you how you're supposed to do this. Is 1 for k equal to 2, or it could be k equal to 1, right? So it's 1 minus 1 squared. It's just that will make one sense. Where so this is in this case it's 3 by 4 plus 1 minus 2 squared. So in this case we have 1 minus 1 by 4 is some part of 1, which could be subtracted from 1. And since when you take the LCM, it just gives you 3 by 4, is 4 minus 1 by 4, it gives you 3 by 4 in this case. And then this is it's equal to approximately 75% of the value. And the probability could be for 3 standard deviations 8 by 9. And it could also be, for a 93% and 95% probability distribution, if it is just for one single, it's just one standard deviation away. So we, from anything above 93% to 95%, and going towards 100%. So we can have this example, just look at this example. Then we can have uniform distributions based on the values of x distributed along with the probability. Now, let's just look at this question first of all. I'm just going to be calculating some values for this. This is a similar fashion. I would like to calculate the standard deviation. Okay. So now Sound City sells the clear cone. Okay, I have to perhaps switch some word so that I can. I don't have a word here. So we have a word here. And I have to minimize system. It's not moving. guys, I managed to adjust somewhat. As you can just look at this question now, I have how I'm supposed to adjust. Now, as it says that Sound City also sells a clear tone 400 satellite car radio for this radio historical sales records over the last 100 weeks show 6 weeks with no radio sold. So we have 30 weeks with one radio sold. So now, for instance, you have X as the number of radios. This is just 0, and the probability of X in this case would be 6 out of 100, which is 0.06. Then you have one radio sold, which would be for this last 106 weeks, no radio sold, and 30 weeks with one radio sold. So it's just one, and it's going to be 0.3 with one radio sold. Similarly, we have 30 weeks with two radio sold. So it's just one radio, and then with a similar number of weeks for two radio sold and one radio sold. So 20 weeks with 3 radio sold. So we have 0.2 for 3 and for 4 radios. Similarly, you have 10 weeks, which is 0.1 in this case. And I just hope that you can really see this. Let me just bring it a bit above. Okay, let's just continue this. Then we have point is 10 weeks with the 4 radios sold, 4 weeks with 5 radios sold. So for 5 radios is 0.04, it's just 0.4. Then we have X of PX in this case. So what could it be? Just multiply them, that will be giving you 0. Then this is again you have 0.3. This could be, and again 0.3 into 2 is 0.6, and again 0.6, and then it's just again 0.1 into 4 will be giving you 0.4, and then we have 5 into 0.04, we have 0.2. You just simply add them up. Could be summation x px. So I'll just write it in clear fashion. X px. Okay. So that could be how much? X is between 0 to n is 5, right? So now we have 0.3 plus 0.6 plus 0.6 plus 0.4 plus 0.2, and we have exactly 2.1. So now we have this as 2.1 in case you can't see. This is 2.1. Then we can, this is our mu. So now this is mu, and now we can have x minus mu here. X minus mu. So this would be this value, which is mu, and this would be minus 2.1 in this case because x minus mu is much. Then we can have 1 minus 2.1, and you get minus 1.1, and then 2 minus 2.1, get 0.1, 0.1. Then you have 3 minus 2.1 as 0.9, and then you have 4 minus 2.1 as 1.9, and 5 minus 2.1 as 2.9. Just add them up, what do you get? It's 2.9 plus 1.9 plus 0.9 minus 0.1 minus 1.1 and minus 2.1, and you get about 2.9 plus 1.9 plus 0.9, 5.7 minus 0.1 minus 1.1 minus 2.1. Okay, so it's just almost 2.4. But now we need x minus mu squared. Okay, so then we don't want any negative values in this case, so we can just have x minus mu squared. So let's just square the values. You can have 4.41, then we have 1.1, we have 1.21, and 0.1, we have 0.01. Notice that the decimal keeps decreasing when you multiply it with itself or any other numbers in decimal. So it's 0.9 into 0.9 and you get 0.1. And 1.9 into 1.9, 3.61. And then 2.9 into 2.9, you get 8.41. Okay. You're going to simply add them up. Then you can have x minus mu squared into px. So now what is this px, which is 0.06? Now I'm going to be having 4.41 into 0.06 is 0.2646. We can have 1.21 into 0.3. This is 0.363. We can have 0.01 into 0.3 and have 0.003. Okay guys, sorry. So now we have, this is for probability of x, which is 0.03. Let me just check this again. So we have 0.01 into 2, 0.0, sorry, it's 0.03, it's 0.01 into 0.3, we have 0.003, then you have 0.81 into 0.2, we have 0.162. I hope you can see this is 0.162. This is 3.61 into 0.1. We have 0.361. And then 8.41 into 0.0 4. The point is 0.04. You have 0.3364. Let me just see. It's visible. Yeah, I guess it's visible. That'll be much better. You guys, trying to zoom in. Hope you can see it more clearly. So I'm going to be adding all those numbers together. So we can have 0.26. Let me just recount in case there is some mistake. 4.41 into 0.06. Then we have 1.21 into 0.3. 0.01 into 0.3. 0.003, 0.162 into, so this is 0.1 into 0.3, 0.81 into 0.2, 3.61 into 0.1, and 8.41 into 0.04. You have all the correct numbers. I'm going to be adding them up. Plus 0.162 plus 0.003 plus 0.363 plus 0.2646, 1.49 approx. So now your variance sigma square in this case is going to be x minus mu square px summation I is 0 to n is equal to 5 px. It's going to be 1.49. So now I'm going to be taking the under root in order to find out the standard deviation, which is 1.49. So now I just hope I can find the standard deviation by taking 49. Gives you about 1.220. This is our standard deviation. We have completed the question. Then you can just talk about the intervals. And similarly, you can just see this. Guys, you can just see, look at this question with calculating probability that x will lie in the intervals. And now with this question, you have to check all these values. I've already done this for you. And for this, just do this plus minus. I've already calculated the sigma for you. Then you can just mu, which is actually 2.1 plus minus sigma, which is going to be 1.22, and 2.1 plus minus 3 into 1.22, and sorry, first of all it's 2 standard deviations, 2.1 plus minus 3 standard deviations. So we'll be calculating. You'll be calculating all these. I have actually completed these parts. So now you have to do other parts, and I'm done with this section. Primarily has all the same questions, queries. I hope that you can just discuss 5.14 once you try to do this as your assignment. This is 5.14. Okay, so I'm going to be checking this up with you, and I'll be posting this as well in the LMS. So guys, thank you so much. Here I'm ending my video, and let's just see you next week or in probably the coming days. So